Okay, so the time has come to repair the wires here because the insulation, as you can see, is very brittle. And for example, this wire here, as soon as you move it, look at that. It's just falling apart. Look at that. It's hard as a rock. So the insulation is no good. So this red one here is the one that goes to the commutator. Is this one. I can replace this because it's not on the winding. But the ones on the windings I cannot, because I'm not going to be unwinding the insulation here. Insulation tape that they put. But this, even the sleeve here, this black sleeve, has gone very brittle. So I'm going to have to cut it off, and then I'll put heat shrink instead. So I'll be cutting that off. Okay. So I don't put too much force on the cables. There's a blade. Okay. So that's off. Slightly bit more softer around here. Now with this one, probably I'm going to have to cut it and join a new one there. And maybe these blue ones as well, the blue one and red. But this one, which is this one here, this is the same there. That's one piece. So if I could manage to probably cut it off here and pull this, and there you go. Now it left the insulation there. I don't think I can pass that on. Maybe if I get a small drill. That goes a bit too big. I started to push it out. I pushed it out, and I'll be able to run that. Okay, I'm going to put a bit of heat shrink here. Okay, and I'll press that in if I can. Okay. Got some mylar tape here. See if we can pass that in. It's not working out. Okay. So now this one, the only thing I can do with this one is break the insulation. Cut this off for now from here. The wire is not the best either as well. I think what I'm going to be doing is cutting it and joining it. So I'm going to cut it here, take this off, okay, and I'll get some wire, and I'll have to do a repair there. Okay, so what I've done here is I took the insulation off, I've cut it off, and I'm going to solder a new wire there, which is this blue one here. I'll have to see how I'm going to make that stronger. All right, what I did, I redone it. This, I have some fiberglass and silicon high temperature insulation. Okay, I cut a bit off that, and I used it as a string to tie the wire with the heat shrink. As the insulation was broken here, so I joined it around here. Okay, and I'm going to put a bit of super glue here so it doesn't get undone. Like that. So that will hold it there, and then that will bend there. And I might do the same here on this one, though this one is actually what it needs is just a little bit of super glue here on the insulation so it doesn't get undone. That's all. So that part's done. I will cut these halfway and join them because these actually go to the coils, and then I'll run some sleeving over it. Okay, so I've cut the wire there, and that's the wire I cut. It's all brittle, the insulation. And here it's still soft around the middle where it had the sleeve. So I'm going to put some flux just to make it easier to solder. Okay. Okay. So after replacing the wires, well, not fully on some of them, I replaced them with silicon wire, and I put the sleeve, the heat shrink, and I put heat shrink around the wires here, and I soldered back the brush terminal, the connector, I mean, for the brush. And this is the brush holder, which slides in the brush holder here. So everything's been cleaned after re-oiling the bush. I cleaned any oil that went around the brush area. So time to assemble this now. So this slides in there, and we'll see if I can be able to push the wire in. Okay, this terminal goes from this side. I was putting it wrong from underneath. I have to go from the side. Okay, so it goes on this part, not on the bottom. There's no room to fit in the bottom. So it had to be like that. Now I still have to fit this one here, the left side from this position. So we'll slide that way. There you go. Everything has to be aligned carefully, not the wires not to get caught on the casing. So, and not to be in the way of the brushes on the commutator, and something like that from the bottom. Okay. Terminal seems to be a bit loose, and I remember that was a bit loose. Let's see if I can make that a bit more tighter somehow. This terminal, how can we make it more tighter? Don't want to alter this because this is where the brush goes. So, but the terminal here, okay, might have to punch this a bit more in to give it a bit of more embossing to fit a bit tighter. All right, I got a bit of a small vise here. So I've got the terminal there. Now see if I can punch it a bit more in, the embossing. To make it a bit more tighter. Give it a bit more. Okay. Okay, so just pushing it in. Definitely it's a lot tighter. almost too tight. But it's going in. Hard to see, not enough light inside. There you go, it fitted tight. So that's what that needed. And that was loose when I took it off, I remember. It sort of slid out by itself. So that part is done. So I've put the armature in here just to test it out and keep assembling. And before, when I was taking it apart, I made a mistake. Those two washers that fell out actually were from the brush, from the side of the brushes side. So inside there, it's got 3 washers. And nothing here at the back. And I've tried adding a washer here. And if I do, then it's going to lock the motor. So that's how they done it. And the reason is, where the commutator is, if I push this more out and take a washer out and put it here, then the alignment of the brush is going to be more close to the edge of the commutator. So it has to be that way. So that's how that was. So I'll be putting this side on. And of course you have to make sure you align. Let's see where we are here. Cannot see. Okay, that way. So I've got marks. And to align the field accordingly to where it used to be. It's got 2 marks. Sorry, cannot see, but it's got 2 marks there. So put the screws in. Change glasses. So this one you got to do them evenly, and we'll be tapping the motor with a nylon hammer, the whole casing, to try to align it. Let's see. And we're spinning it, and we'll keep tightening slowly. Make sure the motor doesn't lock up. The armature, I mean. And check the backlash. It's got to have some. It's spinning. Okay. Keep tightening. That's funny. Before, when I had the washer, was tight, but I still have to make it more tighter, so it might pull it a bit more. A lot smoother than what it used to be. Used to be a lot tighter before. So those bushes were definitely dry. But what I might do, this washer that I found here doesn't belong to it. I'll put it there because on the actual instructions shows that it should have that. And when I put this on, I will lock it to that. So that should stop it moving about. But it's only got minimum play. Might have about 0.7 of a mil. Okay, time to put the top section. I put an extra sleeve here where the wire bends. So the wire needs to bend there. I put an extra sleeve. And that goes like that. Now let me put a bit of blue Loctite on the screws. Okay. So I lost the star washer, believe it. So this is why with the camera, looking what the camera is and trying to do the work. You can't concentrate properly on the job, having the camera underway. Where am I? Not even on the right spot. There it is. Okay, so I got the screws tight. I had to pause it so I can concentrate. Okay. So I'm going to be putting a little copper washer there. We'll be putting the centrifugal governor. And need the Allen key. I could find that. Okay, got the Allen key. Let's see if I can put it where it used to be. Not to put too much marks on the shaft. Around there. Maybe slightly too tight. It'll give it a bit of more backlash. That's better. It's pretty smooth. Alright, it's time to start assembling the speed controller here. So we'll have to put back the contacts. And what I have noticed before, I don't know if you could see, this was wearing a bit to the side. So when it was pulled off before, if it was pulled off, I'm not really sure what happened here. Never focus the phone. You could see it's got two wear marks. One here, and it should be there. Should be in the middle, should be running there. So I'll try to have to centralize it if I can. All right. So this might need adjustment later on. Let's see. We'll have it as much to be center there. And then we'll see how it is once it's put in place. Okay. And you see it has moved. So when you tighten it, it could move to the side. So what we have to do is, I'll put a little maybe a washer spacer here. So when I tighten it, it goes against that. Okay. And the top part's not right. It's got see if I can put that. It's got a spring at the top. Okay, that's better. That's more aligned. Now we'll have to align this, the switch, the points. So the points have been cleaned with solvent after I polished them, filed them and polished them. So it's a matter of aligning it. It looks pretty okay to be aligned with the bottom contact, and it still has some pressure there, which is good. That means it's touching. I might have to move a bit this way. Okay, so you got to use your eyes and make sure it's aligned, and you got to unscrew slightly and move it about. Move it to the correct position where it's aligned properly in the center of the other bottom switch contact. So that's fine. Last check on the tightness. It's pretty tight. Okay, got to watch you don't damage this resistor here. So that's that part. Okay, time to put the speed controller in. And I remember that was 14 mil, the gap. So I had 14 mil. I'll set that now. Okay, so here we're going to be putting the switchback section, the speed controller knob. So this has all been cleaned, so I'll start with putting some grease here and the channel of the cam. This is like an internal cam here. This is actually a bit of graphite grease, which is actually very thin. I'll put some on the shaft. I'll put some on the face here too as well, because this is actually rubs here. So we'll test this. That seems to be very smooth. Okay, put it out again. I'll just wipe off the excess grease. And I'll put this back. Okay. So now I've got the knob that's been repaired with the JB Weld here. The spring goes first. And the knob. And it's got a spring, so I've got to press that. I do have a washer here. Which this washer, I don't think this is original. I think I've put this once before. When I once maybe repaired this knob before. So it helps for the clip not to be running on the plastic. Okay. So there it is there. Now, that's right, that's correct. So now it's a matter of installing the switch. Now the switch, I'll be putting little oil there. So some sort of similar to contact cleaner, except it's got some oil on it. I'll be spraying a bit on the mechanism there and the contacts. Okay. Switch. I think it goes this way. All right, so we got the switch here. I'm going to put some blue Loctite, just a little bit on the screw. I probably should have put the switch first actually, but I already put the other screw, by the way. It's not tight, but I already started it. Okay, so we can see there the switch flicking over, that part there. I'll put some grease where the backlight here part touches the switch. The fork, the switch. Let's see if I can zoom in. Okay, you can see there's a that's the fork of the switch being caught, so I've put a bit of grease. Not sure if this is not really focusing. So I put a bit of grease right in there where it meets the fork, so it doesn't wear out. Okay. There's a little lug here, copper lug, which one side of the capacitor shorts joins to the lug and the lug is to the frame. And that's to cut the noise, frequency noise generated by the contacts points when it sparks, to cut down the noise of interference in the electrical system. Though I believe it would have worked better if the motor was earthed, but it's not. So now it's a matter of soldering the wires back on from the motor to the right terminals. So let me set that up. Okay, so now we're going to be soldering the wires back. So I've routed them where I think they should go, where they used to go, I think. This one goes here, one of the motor on the resistor. So let's see, I'm going to do that. This terminal, because this terminal actually, when I was trying to clean the solder, I wanted to bend it, and one of the tabs broke off for some reason. Very strange. So I'll put some flux there. See if I'm happy with that. I might put it here. No, it's important to try to do routing the wires and the right way, because later on with vibrations or anything, you don't want them to be forcing too much. Okay, there is one more, which is one of the motor wires that goes to the switch here. So, and then the solder won't take. So I managed to put the two wires in. Okay, now just a matter of soldering it, and hopefully it will take. Okay, it's soldered pretty good. I had to clean it and put some flux, because when things are very old, the solder doesn't take that good. Okay, so all the wires are put in place, and even here I recut the wires and resoldered them because they started to fray. So I just cleaned all the wires up just to make sure. I'll give it a check, make sure everything's connected right, and of course we still have to put the brushes in, and then I'll give it a test. So that's pretty much for now. One more thing, this wire here was routed in here, but I've changed it because I've noticed when you're changing the speed, this capacitor here lifts up. So this was sort of creating this tension when it goes up and down, if that wire was routed through there. Because this section is stationary, it doesn't move. But this section moves up and down when you change the speed. So I took the wire out from here and I put it there. I can't remember. I can suppose look at the old footage to see how that was, but I don't care about the old footage. This is definitely, that's how it needs to go. So change my mind on that, and I'm happy with it like that. Now the other thing that I wanted to put is, extra thing, was to put some grease on top of the nylon part. Okay, let's see if you can see there on that nylon part. I wanted to put some grease there, so when that's working, there. So I don't know if I was showing that. I put some grease here, and I could see, because I'm trying to look at the camera, I got some grease there, which I will take off. Okay, so when that touches now, I got some grease. So when the motor is turning, the centrifugal part is going up and down, it's got some lubrication there. So that's it for now, until I hook up the brushes, and I'll hook up the variable power supply, and we'll do it. I'll lower the voltage to make sure I don't cause any, if there's anything wrong, nothing's going to burn out. Alright, time to fit the brushes. And I was using one of those cordless microphones, and was making a lot of noise, so I took that off. I'm just using the actual mic on the camera or on the phone.
So these ones I did mark originally, the brushes, though it's not going to make any difference now because I have cleaned up the commutator anyway. So I remember I put some texture here on the end, which was this way. I'll wipe that off. So that went that way. Actually, I'm just thinking before I put the brush. No, put the brush first, yeah. I was thinking about the gear on the motor. When I hammer the pin that holds the gear, I don't really want to have the brushes on there. But I do want to test the motor first, so there's something wrong here. That way. Okay, so I'll set up the wires, then we can test it. Okay, so ready to test the motor. So I've put the voltage down. We'll turn it on the slow, bring the voltage up. Okay. Maybe I should show where the contacts is. Put up the voltage to 240. And we got still a bit of spark on the contacts. I suppose it's always got to arc a little bit there. Yeah, I mean, probably if those points were new, probably would be much better. But there's nothing much I could do. That's at low speed. So the points have to be, when it's switched off, the points have to be closed, okay? Because if they're fully open, it means that the current's always going to go through this resistor and it will heat up. Even like that, it's hot on the low speed. Though I recall that on low speed it was worse before I took it all apart. Used to cut out a bit more already. It's more smooth. Now it's more smooth. Okay, so I think it should be okay. We'll, you know, once it's back in the machine on load, we'll have to test it again. Make sure it's running right. Okay. So regarding the points or the switch that switch off and on with the speed on the governor, it arcs right when it's on low RPM. So I thought I'll try a varistor across it. So I've soldered a varistor here. We'll do a test at 150 volts input, and you can see that it's sparking. Okay. So now the varistor is not hooked up. Now, if I hook it up, you can see that's sparking like that. When I hook it up, it decreases it. Okay, I'll take the clip off, and you can see it's definitely got more arcs. So I could see a reduction there, but that's only at 150 volts. If I increase to 240 and apply the varistor across the contacts, it does cut it. Still, you see that's high end spark. It does cut it a little bit. So the varistor does help. See, that's off. That's on. Slightly a bit less. Okay. Take it off. Put it back on. It sort of makes more of a difference at a lower voltage. Let's try now at higher speed. That's without the varistor. That's with the varistor. I can see it's still cutting a little bit. On, off. The spark seems to be more brighter without the varistor. See? That's with the varistor, that's without the varistor. So it does make a difference, but you still have arcing. So you still have arcing. So the varistor have made a difference, and it doesn't get hot or anything. That's a 400 and let's see, that's a 430 volt varistor across the points. So I was thinking about maybe putting a triac. I mean, I don't really want to be modifying this too much. That resistor did get hot there, left it a lot on the low RPM. It gets hot. And of course, if the contacts don't make good contact, that resistor will get even hotter. So that's the actual circuit of the motor, right? So we got a snubber here, okay, across the points. That's the points. And when the switch is in the open position, the current goes through the resistor, limiting 450 ohms. It's got a, that's the field, and it's got a choke here as well to minimize noise and limits the current a little bit. And that's the other field and the armature in series, and that's your mains, 240 volts. So I found the circuit that wasn't included in the PDF file of the machine, A701A. And but I did find another PDF file, and they do have a circuit where they've put a triac. And that's what I was thinking about. And this is the way they've hooked it up. So on the 250 volts, they got rid of the choke. See, that's got a choke there. That's on the 120 volts. But on the 250, you know, they didn't bother putting it on. Obviously, maybe they worked out that it wasn't needed. It was less noise going to the mains. It's got a snubber circuit here with a 0.047 and a 56 ohm resistor across the triac. Okay, and then they got a 220 ohm resistor onto the gate coming off the voltage here of this resistor here, 56 ohms. So I was thinking of about trying something like this on it. So I was gonna use a BTA 41, which is a 40 amp 800 volt one, this one that I have. Just to see, obviously if this works, we'll get rid of that, the points arcing. So the points then are only used to trigger the gate, which will be very low current, hardly any current at all, milliamps. So I'll see if I could wire it up and test it and see if that works. Regarding the planetary hub, I did end up buying a second-hand one, because as much as I try to fix it, when I fully tightened the nut, it was actually causing the hub to come still angled to one side. So the bottom part here, that's the old hub, the bottom part, even though I try to fix where it tightens onto the shaft, it was still distorted, and I couldn't have it running to, you know, to a little bit to one side. It has to be straight. So unfortunately you can't buy a new one, but I did manage to find a second-hand one. In the end, it was still loose in the shaft, so the shaft has some wear, the D section. So you can see that's the shape of a D. The D section of the shaft is slightly worn. That's from the constant, as this was very worn before I filled it up with the JB Weld. Even the second-hand one, still had some was still loose, and that's probably as well because of the shaft had some wear. So I still had to put retaining compound, the Loctite, let's see, the Loctite 680. Okay, I still had to put this in the D section and just let it sit, put the nut and let it sit upside down so it doesn't leak into where the bearing is, which is a brass bearing bush, to fill up the gap, to get rid of the looseness and not relying on the tightness of the nut. But when I fully tighten the nut, this hub stays straight. So that is the reason why I replaced this. And of course, this is the original one, is a A701A, which is this one. And this one have slightly larger, a wider skirt here. Okay, so this one came probably from a model after, or some other models, 700, I'm not sure. And it's got slightly a bigger gap. So this skirt is about 2 mil shorter than this. Now, whether the gearboxes were higher around here, I don't know, or they decided to do that because they had problem that rubbing, maybe it was too close, I don't know. But I still had to put, how I said, without this it will wear out. But I could have put this, which I did, in the old one, but when I tightened the nut, how I said, it was tilting it, was getting the tilt, and I couldn't really fix that anymore than what I tried to do. I made it better, but not good enough. So that's it. That's that about the gearbox.